Hello friends, today we'll be discussing the complete solution of NEET 2020 Physics. Okay, it was comparatively a simpler question paper this time compared to the previous years. So to give you a full analysis of what the question paper is, what the solution is, do watch the video until the end. Okay, and share with all your friends so that they get an idea about how the question paper was and going to be for the next year. Those who want to repeat, or those who are studying in the 12th standard and they want to approach the NEET examination the next time. So this video is for all of you. I have uploaded a video in the earlier case also. You can check it out the same night when the NEET examination was. It means yesterday night itself. In the evening the NEET exam finished, and the evening itself, night itself, I have uploaded the complete solution. You can go check it out. So this is a reshoot of this. Okay, thank you. Let's go into the question. So let's start with the first question. I'm doing this particular question paper is G3. The code is G3. So you can match it with your code, which can be any code of yours. So just look at the questions so that you understand which question is which. Okay. In my question paper, my first question starts at 91. So let's look at this particular question. 91. The phase difference between displacement and acceleration of a particle in a simple harmonic motion is given. Harmonic motion is 3 pi by 2 radians, pi by 2 radians, 0 and pi radians. So what's the answer? Between the distance, displacement equation and velocity equation, the phase difference is pi by 2. With velocity and acceleration is pi by 2. So that the phase difference between displacement and acceleration is pi radians. So the fourth option is the right answer. 92. A long solenoid of 50 centimeter long is having 100 turns. So let me slide it up. 100 turns carries a current of 2.5 ampere. The magnetic field at the center of the solenoid, you know that total number of turns is given 100. So the current in the circuit is 2.5 ampere. So let me write it down again. 2.5 ampere. The length of the solenoid is 50 centimeter. You have to convert that into meter. So you know that it's equal to 50 into 10 to the power minus 2. Okay, now the equation for magnetic field at the center of the solenoid is very, very simple. Nu naught Ni. So it's equal to, you can write it as nu naught into, let me check if you can see this. Yes. So nu naught into capital N, that is the total number of turns, divided by the total length into the current I. So when you substitute all those values, I have found out the answer for you. You will get the answer as 6.28 into 10 to the power minus 4 Tesla. So that's the right answer. Now let's look at the next question. That is question number 93. Fourth option was the right answer for 92. Okay, for question number 93, two bodies are hanging with 4 and 6 kilogram are tied to the end of a mastless string. The string passes over a pulley which is frictionless. Okay, the question is to find out acceleration. It's a very simple equation. A is equal to the bigger mass, let's call it m1, minus a smaller mass m2 into g divided by the sum of the masses m1 plus m2. This is a question from the system of particles and rotational motion. Okay, now if you substitute this, bigger mass is 6 minus smaller mass is 4 into g divided by 10. When you analyze this is going to be equal to g by 5. That is, the second option is the right answer. Now let's look at the next question. It's even a pretty simple question. The contribution of the electric field and magnetic field to the intensity of an electromagnetic wave is. That means, according to this question, they are trying to ask you what is the contribution of electric field and magnetic field to the intensity, and found that electric field and magnetic field do contribute same value. So you'll find that the first option is the right answer. Okay, so now let's look at the next questions. In a certain region of space of volume 0.2 meter cube, the potential, electric potential, that means the region is 0.2 meter cube, let's call it. Okay, the potential is 5 volt throughout. That means if the potential is distributed equally throughout, what will be the electric field? The electric field will be zero. Electric field will be only there when there is change in potential difference. But in throughout the volume, the potential is same. Then the answer is going to be the fourth option. Okay, now the next question. The average thermal energy for a monoatomic gas, that is question number 96. The average thermal energy for a monoatomic gas, Kb, is equal to Boltzmann's constant, T is the absolute temperature. You know that the average thermal energy for a monoatomic gas is 3 by 2 kBt. Okay, that's the first option is the right answer. Now, if there is any disparities between my answer and yours, you can put them in the comment section below. We'll analyze this and update you in the comments itself, so you can analyze this. Okay, find the torque about the origin when a force is given 3 j cap Newton. Okay, and a particle acting in the position vector is given. Position vector is R is equal to 2 k cap meters. 2 k cap meters. So what is the torque acting on it? Torque is equal to R vector cross F vector. R cross F. R cross F. Here the question is K vector is coming for R and J vector is coming for F. If you are taking the cross product of K cross J, you will get minus I. If it is opposite, J cross K, it will be plus I, but here it is minus I. K cross J is minus I. So what is the final answer? 3 into 2 is 6. 6 of minus I. That means what? That's the second answer is the option is the right option. So now let's look at the next question. Now in this particular question 98, the mean free path of a gas molecule you have to find out. Just very simple. You know that lambda is called the mean free path. Lambda is equal to 1 divided by root 2 n pi d square. The equation is a straightforward equation. That is the first option is the right answer. Now the next question. 99, the energy equivalence of a 0.5 gram of a substance is, the energy equivalence is, how much is the energy equivalence? Equivalent to that particular mass, which is E equal to mc square. If I substitute that values for m, mass is 0.5, which is 0.5 into 10 to the power minus 3, that is kilogram. Kilogram into c square, that is 3 into 10 power 8 meter square. Right, when you substitute all those values, you will probably get an answer as 4.5 into 10 power 13. 4.5 into 10 power 13 joule is the right answer, which is the first option is the right answer for you. Now let's look at the next question. Question number 100 in my question paper. This is a screw gauge question paper, which is can be done those who have done proper practicals in their board examination, or those who have done practicals in their day classes, in their ordinary regular classes properly. A screw gauge has a least count of 0.1 millimeter. Right, least count is given. 0.1 millimeter. You know the equation for least count of a screw gauge. Very simple. Least count is equal to pitch divided by total number of divisions. So you have to calculate pitch here. Pitch is equal to least count multiplied by the total number of divisions. When least count is 0.1 multiplied by 50. 50 is the total number of divisions which is given. When you multiply least count 0.1 millimeter with 50, pitch of the screw gauge it is, what I was saying is 0.01 millimeter, it's 0.01 millimeter is the screw gauge pitch, least count is 0.01 millimeter, and for the vernier calipers it is 0.1 millimeter. Okay, I've written the first case for vernier calipers, but now the question was screw gauge 0.01 millimeter, multiply with the total number of divisions with the 50, which will give you 0.5 millimeter. Okay, now let's look at the next question. There are two cylinders A and B of equal capacities connected to each other by a cork. A contains an ideal gas, standard temperature and pressure is given, and B is completely evacuated. That means we can call this as vacuum. That means there are two containers which are joined together. One is completely vacuum, the other is at standard temperature and pressure. So when the cork is opened, what happens? The pressure difference finally happens at a very faster pace. So that what kind of a process it will be? It will be an adiabatic process. If the pressure difference happens very fast, such process connected to us is the adiabatic process. Okay, 102 is the next question. A cylinder contains hydrogen gas. You know the molecular mass of hydrogen gas, M is equal to 2 upon 1000 kilogram per mole. right? Kilogram per mole. Okay, and the pressure is given 249 pascal. You have to convert that into 249 kilopascal, that is 249 into 10 power 3, and the temperature is 27 degrees Celsius. Temperature is given as 27, which is equal to degrees Celsius, which is equal to 300 Kelvin. Right, so what you're going to find out, you're going to find out the density. The equation for pressure as far as density is concerned, rho RT divided by m. So as from here you can find density is equal to P into molecular mass divided by R into T. If you substitute those values, you will probably get 0.2 kilogram per meter cube, 0.2 kilogram per meter cube. Okay, so what's the next question? Uranium isotope, which is 253, is the atomic mass, and the 92 uranium 235 is bombarded with a neutron. So what is neutron? 0n1 is bombarded with a neutron for uranium, that is 92 uranium 235, which gives you bombarded with the neutron. It generates krypton with 36 and 89. So it's very simple question. I'm giving 3 neutrons. That means 3 neutrons are there, 0 and 1. That means in the mass number for neutron will be 3 already there. Here 89 is there. When you add it together, you have to get 236. Why? In the left hand side, the total mass number is 236. You have to get the number, which is definitely, you know that how much you have to add it together. You definitely have to add it. Remaining is 144. Yes, okay. Now in the left hand side it is 92, the right hand side it is 36, and the remaining has to be 56. That is, if you look at the options, you will find that it's barium. Yeah, so barium is the right answer. Okay, right. Now let's look at the next question. A charged particle, having drift velocity is given, right? Okay, drift velocity is given, and the electric field is also given, right? Okay, now drift velocity is given, electric field is given. You have to find mobility. Mobility is equal to drift velocity per unit electric field. You have to just divide the drift velocity value, which is already given in SI unit meter per second, and the electric field also in volt per meter. You don't have to convert anything, just have to substitute it. You will probably get an answer 2.5 into 10 to the power 6, which is the first option is the right answer. Do it and see. Okay, so the next question. What is the total significant figures in the final value of 9.99 minus 0.0099? If you look at the two numbers, you will find that the number with the least significant digit is the second number, which is 2 only. That means after the decimal point, zeros are there, which is not significant. 99 is the only two numbers which are significant. So that the total number of significant figure is 2. After subtracting 9.99 with 0.0099, you will get an answer which has to have only 2 significant figures. So what is the right answer? The third option is the right answer. Okay, so let's look at the next question. 106. Right over my head. Okay, an iron rod of susceptibility 599 is subjected to a magnetizing field. Magnetizing field is not important here. The permeability of the material of the medium. Permeability is equal to mu naught into 1 plus chi times m. What is chi? The susceptibility of the material. Susceptibility is given 599, but you have to substitute it here. 1 plus 599. 1 plus 599 is 600. That is definitely multiplied by mu naught, which is already known to you. What is given? It is already given also. 4 pi into 10 power minus 7. When you multiply that together, which is that 600 multiplied by 4 pi into 10 power minus 7, you will get an answer as 2.4 pi into 10 to the power minus 4 Tesla, which you can do it and see. I have done it myself, so I am giving you that answers. Okay, right. These are done by myself, so I know these values you are going to get. Okay. Yeah, a special conductor of radius 10 centimeter has a charge of 3.2 into 10 power minus 7 coulomb distributed uniformly. What is a magnetic field at a point 15 centimeter away? When I first read this question, I thought that this number is going to be less than 10 centimeter, but they have given it as 15 centimeter. That means definitely out of the sphere. Since it is out of the sphere, the equation for electric field becomes very, very simple. What is that? 1 by 4 pi epsilon naught. What is the charge given? That you have to substitute divided by r square, which is 15 centimeter square. That is 15 centimeter square. That you have to convert that in a meter. You have to substitute it as 15 into 10 power minus 2. Then only it becomes meter, the whole square. You substitute the charge. 1 by 4 by epsilon naught, you already know it as 9 into 10 power 9. You will get an answer definitely 1.28 into 10 to the power 5 Newton per coulomb. That's the right answer, which is the first option is the right answer. I hope you could see this. Okay, 108. You can rewind this video and watch. Series LCR circuit is connected to an AC voltage source. When L is removed from the circuit, the phase difference becomes, that means only if L is removed, C and R only is there, resistance and capacitors only is there, it has a phase difference of pi. So if instead C is removed, that means L and R is there, that means for both L and C, they have a phase difference of pi by 3. So the power factor, you know the equation for power factor, cos phi is called the power factor. We just have to substitute it, cos pi by 3. Cos pi by 3 is 60 degree, cos 60 degree as 1 by 2, which is the first option is the right answer. Okay, if you have any disparities, definitely put them in the comments below. Okay, another one, 109. Yes, this can be the only question which is a little lengthier, but it's also a very simple question. A capillary tube of radius r is immersed in water with the water rises to a height of h. The mass of the water in the capillary is 5 gram. Okay, wonderful. Another capillary of radius 2r is immersed in it. The mass of the water this time rises equal to, definitely you know that the height to which the water rises up into the radius of the tube is always equal to a constant. If you have studied the theory properly, it's also a constant. So that I can write it as, the first case it was rising to a height h, then the radius is r. So in the second case, how much we don't know, h dash into the radius is 2r. So how much will be h dash is equal to h by 2. So you have understood that that's the case. Now what is the equation for mass going up? So that the mass equation is equal to pi r square times h multiplied by the density. So in the new case, the new mass will be equal to pi, what will be the radius? The radius is 2r square multiplied by h dash. What is that? The new height to which water rises into the same water. So I'll get it equal to, yes, 2 square is 4. That means you'll get it as 4 into pi times r square multiplied by h dash. H dash is h by 2 times density. So when you cancel this 2 and 4, you'll get 2 pi r square. Yes, 2 pi into r square h times density, which is equal to 2 times the original mass. Original mass which was given in the question was 5 gram of water was there. Now in the new case, how much mass will be there? The new case, 2 into 5, which is equal to 10 gram. 10 gram of water is now there inside the capillary tube. So what is the right answer? The right answer will be, yes, the right answer will be 10 gram right over there. Okay, now let's look at the next question. I believe you understood it. Okay, in a Young's double slit experiment, you could slide it up a little bit up. So in a Young's double slit experiment, if the separation between the coherent source is half and the distance of the screen from the coherent source is changed, that means you doubled, then what happens to the fringe width? We already know that beta is equal to lambda into capital D by small d. Small d is the distance between the slits, capital D is the distance from the slit to the screen. So when you substitute it, you will have beta dash is equal to, let's put it as a beta dash, which is called the new bandwidth, which is equal to lambda of the light remains the same. Then the separation becomes 2 times the original separation divided by the distance between the slit is half, that means d by 2, which will go up. This will go up, giving you 4 times lambda capital D by small d, which will be 4 times the original value, 4 times beta. So I believe that you could see this. You could see this, yes, 4 times beta. So that is the right answer for you. Okay, so let me slide down with the next question. So 111 for the logic circuit shown, the truth table is what? What's the truth table for this? So let's write it down. So what is this A naught? Let's put it A naught here. This is B naught. So as this comes for the OR, you can put it as A naught or B naught, and after the output is naught again, so it's naught, which is equal to, when you apply De Morgan's theorem, you will find that this is double naught and B double naught and A double naught will be equal to A and B. So from this you will be able to understand that the fourth option is the right option, which is for the AND gate. Okay, the color code. Now we have the color code question. It's also a very simple question. Yellow color, violet color, brown color is for a multiplicative factor. So yellow color is having a number corresponding to it as 4. Violet color is already having a value 7. Brown is having 1, and orange have a plus or minus 5%. It's 12.7, so it is equal to 47 into 10 to the power 1, which is 1 over there, plus or minus 5%. What is the answer? For 470 ohm. 470 ohm plus or minus 5%. That is, the third option is the right answer. 113, the capacitance of a parallel plate capacitor with air medium is, that means with air medium it is given as 6 microfarad. Okay, right. If the introduction of the dielectric medium, a dielectric medium is introduced inside it, the capacitance becomes 30 microfarad. That means the new capacitance is equal to epsilon times epsilon times C naught. Yes, C naught. So it's equal to when you have to find out the special permittivity, C is given. The new capacitance becomes equal to 30 microfarad. Just have to substitute those values. You will get epsilon is equal to, that means the permittivity of the medium is equal to the original new capacitance divided by the air capacitance, which is equal to how much? 30 divided by 6 microfarad. Microfarad cancels off. 6 5 times is 30, which will give you the third option as the right answer. So let's look at the next question. Next set of questions. So 114, it seems. Yes, 114. Ball is thrown vertically downward. Yeah, thrown vertically downward to a velocity of 20 meter per second. So initial velocity, you already know it as 20 meter per second. It is downward direction. Initial velocity, you positive direction are taken from the top of the tower. It hits the ground after some time with a velocity. A final velocity, you know that final velocity is 80 meter per second. Okay, it's a very simple one. The height of the tower is, how much is the height of the tower? G is given 10 meter per second. So it's a very simple question. You can just have to substitute u square minus v square minus u square is equal to 2g times displacement. Let's call it h, which is the height of the tower. So when you substitute this value, g is 10, v square you have to substitute it 80 square, u square is 20 square. Just have to substitute it. You get the final answer, which is a very simple answer. You can directly find out. You will get it as third option is the right answer. Okay, now 115, a body weighs 72 Newton on the surface of Earth. What is the gravitational force on it at a height equal to half the radius of the Earth? That means height is equal to half the radius of Earth. What is the equation? The new height weight is equal to the original weight into r divided by r plus h, the whole square. So if I substitute those values over there, h, you just have to substitute it. You will get the original weight is equal to, original weight on the surface of Earth is equal to, how much is given? 72 Newton. 72 Newton is given. 72 into r divided by r plus h is r by 2, the whole square. That means when you take the LCM in the denominator and the 2 goes up, this will give you 2r plus r. This will give you 3r in the denominator. R and r cancels. That means 2 in the numerator divided by 3 in the denominator. You square it, you will get an answer is equal to, that is you are going to get an answer is equal to 32 Newton, which is the first option is the right answer. Now next question from center of mass question, 116. 116, two particles of mass 5 kg and 10 kg respectively are attached to the two ends of a rigid rod of length 1 meter. That means length of the rod is given 1 meter with negligible mass. The center of the mass, the calculation for center of mass from the 5 kg mass will be, let's imagine that the 5 kg mass is kept at the origin, so that you can apply the center of mass equation. X for the center of mass equal to m1 x1 plus m2 x2 divided by m1 plus m2, right? m1 plus m2, just have to substitute x1, it should be equal to 0. Why? Because the position of 5 kilogram mass is at the origin, so you just have to substitute 0 over there. That is 1. m2 is 10 multiplied by 1 meter, that's the 100 centimeter. You can directly substitute the 100 centimeter for x2 and divided by total mass, that is 5 plus 10. So you will probably get an answer is equal to 67 centimeters. That's a very simple question, which I was totally expecting this time. Okay, those who have studied this, you know that I've already told that the question will be definitely coming from there. Right. The increase in the width of the depletion region in a PN junction diode is equal to depletion region's PN junction depends on what? It depends on the reverse bias only. It does not depend on the forward biasing. Yes. Now the next one, 117, the first option is the right answer. Now 118, light of frequency 1.5 times the threshold of frequency incident on a photoelectric material. Yes. What is a photoelectric current if the frequency is half? That means if the frequency changes, the photo current doesn't change. The frequency only depends on the energy of the electron which are emitted. So then the next part of the question is intensity is doubled. Definitely as intensity changes, the photocurrent changes. So as the intensity gets doubled, the photocurrent also becomes doubled. That is 118. The fourth option is the right answer. Okay, now next look at the next question. Yes, 119, light has a wavelength of 600 nanometer, which is given. Lambda from a star, the limit of resolution. The question is for limit of resolution, which is equal to d theta 1.22 lambda divided by d. It's a very simple question, right? Limit of resolution. How will you find the least resolving power? Reciprocal of the limit of resolution, just have to substitute that value's diameter is already as 2 meter, which is given there. Nanometer, 600 nanometer, 600 into 10 power minus 9, you substitute it, you will probably get an answer 3.66 into 10 to the power minus 7 radians. Now let me slide to the next question. Yes, question number 120. The resistance wire connected to the left gap of a meter bridge balances a 100 ohm resistance in the right gap. That means there are two gaps. In the left gap, let's take it as X. The right gap, it is 10 ohm, which gives you a balancing length in the ratio 3:2. That means 3:2. That means they are equal. Just take the cross multiplication, you will get X is equal to, X value will be equal to, let me see if you can see this. Yes, X value will be equal to 15 ohm. The X value will be equal to 15 ohm. So that 15 ohm, but it is said that if the length of the resistance wire is given 1.5 meter, that means the length of the resistance wire was already 1.5 meter for a 15 ohm resistance. That means you have to find out then the length of 1 ohm of the resistance wire is. That means for 1 ohm resistance wire, 1 ohm resistance wire will be equal to how much? 1.5 meter divided by 15 ohm. 15 ohm. That means for 1 ohm, how much will be the length of the resistance wire? That was the question, which is you will find it as 1 into 10 to the power minus 1 meter. You can substitute it and see. Okay. It's a very simple question. Now let's look at the next question. 121. Light with an average flux of 20 watts per centimeter square falls on a non-reflecting surface. Now the surface area is given 20 centimeters square. The average flux is given. That means the total flux or the power you can calculate. Power is equal to the 20 watts divided by centimeters square. When you multiply it with the area, to what's the total area given? 20 centimeters square. When you multiply this together, you will get it as 400 watts. The power is given. Now the energy received on the surface during in a time span of 1 meter. What is the energy equation? Energy equation is equal to power multiplied by time. Time you have to convert that into second. 60 seconds. Power is given 400. Time is 60. Just have to multiply those together. You will get an answer 24 into 10 to the power 3 joule. Second option is the right answer. Okay, now 122 shows question from prism. A prism at an angle of incidence I on one surface of a small angled prism. Yeah, it's already said that's a small angled prism. The angle of the prism is very, very small, and the light emerges normally from the opposite surface. That means from here it comes normally out, so that when you draw the normal over here, the incident light is this. It comes out normally. That means angle of emergence will be equal to 0, right? Yes, if the refractive index of the material of the prism is new, then the angle of incidence is angle of emergence is equal to 0. But you already know that angle of incidence plus angle of emergence is equal to angle of the prism plus angle of deviation. Angle of emergence is equal to 0 means I will be equal to A plus delta. Now let's look at the refractive index equation. Nu is equal to, let me rub this all these things. So nu is equal to sine of A plus delta divided by 2 divided by sine of A by 2. So when you substitute all this, you will find for small angle the present sine theta value is also very small. You can substitute it as A plus delta divided by 2 divided by A by 2. The 2 and 2 will cancel. You get it as A plus delta divided by A. A plus delta, as you already know, it's equal to I, so that you can substitute as nu is equal to I divided by A, which gives you I is equal to A times nu. The equation is the second option is the right answer. Now look at the next question, 123. Now the question is again a very simple question. For 40 microfarad capacitor is connected to a 200 volt 50 hertz AC supply. The RMS value of current. The RMS value of current is equal to RMS value of voltage, which is 200 volt, which is already given, divided by XC is equal to XC, which is called the capacitive reactance, which is equal to 1 by C omega. So 1 by C omega, when you put it down there, this will go to the numerator. This becomes C omega. So it's equal to 200 into capacitance is given as 40 microfarad, it is 10 to the power minus 6 into omega, that is 2 pi times frequency is given 50 hertz, 50 multiply it out 123, you will get it as 2.512 ampere. 2.512 ampere is approximated to 2.5 ampere. Okay, 124 is the next question. 124, you have the dimensions of stress are. What is the dimensions of stress? The stress do have the same dimensions as pressure. We know that the pressure is equal to force acting by unit area. What is the dimensional formula for force? ml T power minus 2, ml T power, I'll write it down for you. T power minus 2 divided by length square area, that is length square, you will get it as ml to the power minus 1 T to the power minus 2 is the third option, is the right option. Then next question. The Brewster's angle, IB for an interference should be, what is the Brewster's angle they have asked? That means that definitely the refractive index and the Brewster's angle are connected. What is that? Tan IP is equal to the refractive index. You know that the refractive index cannot be less than 1. It's totally meaningless. Now, it cannot be more than infinity. But what is the value of tan theta, where it lies between 1 to infinity, which is definitely between 45 degree angle and 90 degree. Cos tan 90 is infinity, tan 45 is 1. That means that definitely the value should be lying between that. So what you can understand from here is the IP value should be lying between 90 and 45. Just common sense, that is it. Okay, so what is the next question? Let's look at the next question. So if I slide it down, just hold on. Yes, the wire, the question is from here, from Young's modulus. Yes, a wire of length L, cross section area is A, is hanging from a fixed support. Yes, the length of the wire changes into L dash when a mass is suspended. Now, what is a Young's modulus? Young's modulus is equal to F divided by A divided by delta L by L, which is giving you L by delta L. What is delta? What is the force acting? Definitely M is hanging there, so that M into G divided by A into L divided by increasing length, original now new length minus the original length, L dash minus L, which is the third option, is the right option. Now let's look at the next question, 127. 127, we have an electric dipole having a dipole moment of 16 into 10 power minus 6 kilometer. The electric potential due to the dipole at a point at a distance of 0.6 meter. Very simple question, and situated in a line making an angle of 60 degree with the dipole angle. So what's the equation for potential? V is equal to 1 by 4 pi epsilon naught P cos theta divided by R square. Substitute it, everything is given in SI unit. R distance also given in 0.6 meter, definitely that is also in SI unit. You just have to square it. You substitute dipole moment P, dipole moment is given as 16 in 10 power minus 6, given cos of theta is definitely from the dipole axis, that is also given as 60 degree, cos 60 degree as 1 by 2, just have to substitute it. You will probably get an answer 127 as for 127 as 200 volt. 200 volt. I have done it myself and seen it. So it will give you 100 and 200 volt. 128. Yeah, this is a pretty tricky question from the last chapter called waves of +1. In a guitar, two strings A and B made of the same material are slightly out of tuned and produces beat frequency of 6 hertz. That means when you're beating frequencies, two frequencies which are played together, you get a beat frequency mu A minus mu B is equal to 6, which is given. Okay, when the tension in the string is slightly reduced, what happens to the tension and frequency? Let me slide it up for you so that my head doesn't come in between. So the frequency is equal to 1 by 2L into square root of T by mu. Tension divided by mu. So as the tension in the string, in the second string, tension B is slightly reduced, what happens to the fundamental frequency? The fundamental frequency comes down a little bit. So definitely mu B will come down. If mu B will come down, definitely what has to be with the value? Definitely as mu B comes down, this value the beat frequency has to increase. Definitely they are increasing saying that the beat frequency increases to 7 hertz. If the frequency of A is 530, what is the frequency of A? 530. 530 minus mu B is equal to 6. Yes. Now what should be mu B? Mu B is, if you look at the options, you'll get, if I take the first option 524, you will get that 530 minus 524, 6. Definitely you're getting it. But at the same time, the next part of the question, as the tension in the string is slightly reduced, what happens? The frequency should come down. Let's imagine that it comes down from 524 to 523. Then what will be the subtracted value? 530 minus 523, how much? 7. Definitely you are getting that value. So the first option is the right option, which I found directly from the first option itself. So that was fine. You can check it with the other options as well. Yes. 126. An electron is accelerated from rest, yes, with a potential difference of V volt. If the de Broglie wavelength of the electron is 1.227 into 10 power minus 2 nanometers, okay, the potential difference is how much? The wavelength is lambda is given 1.227 into 10 power minus 2 into nanometer is given 10 power minus 9. You will get it as equal to 1.227 into 10 power minus 11 meter. Okay, now the potential will be equal to, what will be the equation for de Broglie wavelength? Lambda is equal to, yes, 12.27 in angstrom. Okay, in angstrom divided by square root of potential. If you substitute this, you will get it is equal to V equal to, what will be V equal to from here? V equal to is equal to 12.27 angstrom value divided by lambda the whole square. This angstrom will be 10 power minus 10. In the denominator, you are already getting as 10 power minus 11. So as this value goes up, you will get 10 as a multiple factor. Okay, and then you just have to substitute the value of lambda. You will probably end up with a third option as the right option. You can do it and see. You will definitely get the answer. You will definitely get an answer as the third option. Now look at the next question for 130. The solid which has a negative temperature coefficient or resistance, you already know that negative temperature coefficient is only applicable for semiconductors. All other cases, what is that? Resistance equation is R is equal to R naught into 1 plus alpha delta T. As temperature increases, resistance probably for metals increases. So insulator is already infinity. So semiconductors, as temperature increases, resistance decreases. For to get that value, alpha has to be a negative value. So for semiconductors only, right? Now the next value, the energy required to break one bond of DNA. That means energy is given. The value of electron volt nearly is, how much is the electron volt? 1 electron volt, you already know, it's equal to 1.6 into 10 to the power minus 19 joule. So if you want to convert that 10 to the power minus 20 joule, yes, you have to convert that. What you have to do, you have to find out the value of the energy in electron volt. That means the energy in electron volt, you just have to do it, yeah, 10 to the power minus 20 divided by 1.6 into 10 to the power minus 19. You just have to divide this value. You are going to get 0.06 as the right option, which is the second option is the right answer. Okay, so the third option, the 132, the quantity of heat required to raise the temperature of two solid sphere of mass radius R1 and R2 through 1 Kelvin are in the ratio. Which is the ratio? What is the equation for that? Now, the amount of heat energy required is equal to ms delta T, right? Mass multiplied by specific heat multiplied by rise in temperature. You can put it as 1. Okay, 1 Kelvin. So what will be Q1 is equal to volume multiplied by density for mass. Okay, density multiplied by specific heat multiplied by delta T. So specific heat is the same for the material. Why? Because it's copper, it is already said. Delta T, rise in temperature, is 1. Density of the material also is the same, copper itself is. So Q1 depends on volume. What's the equation? Q1 divided by Q2 is equal to how much? Volume is 4 by 3 pi r cube. Let's put it r1 cube divided by 4 by 3 pi r2 cube. So when you put it as r1 divided by r2 the whole cube, what is that? R1 divided by R2. R1 by R2 is already given. R1 by R2 is already given as 3 by 2. Why? Because it's equal to R1 divided by R2 is 1.5, which is 3 by 2. Substitute that value there and cube it. You will get as 27 divided by 8. Okay, which is the fourth option. Now 133, you have an option. The question is to find out the resistivity with temperature. As temperature increases resistivity, what happens to copper, that is a metal? What happens? The resistivity will drastically increase. Okay, that's the next one. Then we go to the last set of questions. 134, for a transistor action, which of the following statement is correct? Okay, now if you look at it, 134, the base region must be very thin and lightly doped, which is already said in the theory part. It has to be lightly doped, otherwise it is not going to work out for transistor action, as a transistor action. Why? Because all the majority charge carriers which reaches the base has to go fast into the collector region, and it has to be thin, it should be lightly doped. Okay, for which of the following Bohr model not valid? Singly ionized helium atom is the right answer. That's no problem. Deuteron atom, definitely it is an isotope of hydrogen itself, definitely is possible. Hydrogen atom, it's not a problem, but singularly ionized neon atom is definitely not possible, which can prove Bohr's model of the atom. So these are the sets of answers, and I found that the question is pretty simple. Certain questions only you will take more than 1 minute or 2 minutes, which if you are thinking, you can take it, but it doesn't feel that it will take too much of a time. So watching this video, if you like it, put a thumbs up and you share it with all your friends. If you're new to my channel, put subscription and put the bell button so you get all my notifications whenever I upload a new video for you. Until with the next ideas, next questions, next question papers, next new things. Bye.